So when we start talking about translating equations, we are going to use the exact same rules and theories that we used when we were translating expressions. The only exception is, of course, that we've got to deal with the equal sign. And almost always you're going to see something that looks like is equal to. So the bottom line here is the first thing we're going to do is translate. And we translate these in the same way that we translate, or rather that we solve an equation. We translate each side on the equal sign and making sure that we place the equal sign correctly. We just put that equal sign in there. On the left-hand side, we have 2 plus a number. So that's 2 plus a number. There's our is equal to, and it's 4. So now we've got this lovely little equation, and once we've identified that equation, all we have to do is solve it. So how do we solve that? We simply isolate the variable, and we're left with x is equal to 2, and we're done. So we're going to look at this next one, and this one I have the 2 in there, and remember that is special. It is something that flips the order if we're trying to be precise about our translations, and we're going to try to be as precise as we can be. And we see that we're adding. So we are adding. What are we adding? We're adding 3 and a number. This 2 is flipping the order, so it's x plus 3. Here's our equal sign, equal to, and of course it's equal to 8. And now we just solve this the same way we solve any other equation. So the opposite, that's gone, x is equal to 5, and we're done. We translated the equation and we solved. We use the same ideas, like I said earlier, and that is, we're always looking for those exceptions. So sometimes the operation is listed first. That was one of our examples that we had earlier in the previous video on expressions. So here we have the sum of. So we've got the sum of. What do we have the sum of? We have the sum of 3 and a number. So 3 and a number. It's equal to 5. So we make the translation, and as soon as we made that translation, it's really easy just to say, okay, now I'm going to get the variable alone by adding the opposite, and x is equal to 2, and you're done. And then, of course, we have the ones that flip the order, and we're looking for the than, the from, and the to. So again, for less than a number. So remember, we're looking for to simplify the expression on each side of the equal sign. So in this case it says for less than a number, so less, that than is switching the order. So it's x minus 4 is equal to 8, and then we simply solve. So again, plus 4, so x is equal to 12. When we look at this next one, it says b is 10 subtracted from a number equals 13. Well, there's our equals, so we know that we are, this is our expression on the left side here. We see subtracted, so we know it's a minus, and we see that we've got a number and 10 that we are subtracting. The from, of course, is flipping the order, so it's a number minus 10 equals, or equal to, 13, and solve the same way. We get our variable alone, add 10, do it to both sides, and we get x is equal to 23. You may notice I'm going through these a little bit more quickly, but remember that these are really just a repeat of things that we've already done. The only thing that we've added here is an equal sign. Here again we have 7 added to, so that 2 is again flipping the order. We are obviously adding. There's our equal sign, so we're adding. What are we adding? We're adding a number and 7. The 2 flips the order, so it's x plus 7. There's our equal sign, 9, and again, we just very quickly isolate that variable. And we've translated and solved pretty quickly. And remember, we've got this last exception where we need the parentheses. We identify that because we see that we've got an operator acting on an operator. There is, let's see if we can find our equal sign. So that is equal to. We see times the sum, so we have 2 times the sum. We are adding 3 and a number. That is equal to 20. And now we have to solve this thing. So the first thing that we're going to do is distribute. And then we get rid of the constant, which is helping us isolate the variable term. And now to isolate the variable completely, we just divide out the coefficient so that we say x is equal to 7. And we're done. The next one, same process, but again, we have to read to be careful that we are doing what we're supposed to be doing. So this says the sum of 2 times a number and 3 is equal to 11. So we identify, here's our is equal to, so there's our equal sign. We see that we've got a sum, so we're saying the operator first, and then what are we adding? We are adding, let me go get a different color really quick. We're adding, I thought I had a different color. We are adding, there we go, 2 times a number and 3. So 2 times a number is 2x. So I'm adding 2x and 3. Here's my is equal to 11. And now I'm just going to go ahead and solve this thing. Get the constant term. Goes together on the other side of the equal sign. Our variable equal to constant, and we divide out the coefficient to get the variable completely alone, and we're done. So we make our translation, and then we just solve it as we would solve any equation.